RostyMaths, and how are you doing today? Well, oh, can I call you that, RostyMaths? Well, you're here, so you might as well subscribe to the channel. Anyway, hello, how are you doing today? Well, as you can see, we are getting back to our Year 9 Algebra series, and we are trucking through it quite nicely. So if you have missed any of the other videos before, I will put a link to the playlist up here. Just click on that playlist. You're going to have all the videos and in the right order as well. And that's the order that we are doing. Now, as you can see, we have gone through some bracket work in the most recent videos. And now we're going to go back up here because we needed to get the brackets done before we can do the bits that I wanted to do up here. It's going to go back up here. We're going to go into this lesson on identities. So without further ado, please make sure that you stick with me now as we go through identities. Before we continue, please don't forget to subscribe to this channel and hit that notification bell so you will know as soon as a new video has landed. Okay. Identities. Well, what does it all mean? It's not that little card you show to show your identification. When it comes to maths, identities are represented in a specific way. And normally, I can say that 2a is equal to 10. I can say that. And that is provided that a is equal to 5. Because if a is equal to 5, then 2 times a will be equal to 10. But that's not an identity because a is a variable, and a variable can change. If the value of a changes to, say, 10, then 2a will no longer be 10, it will now be 20 because a has changed its value. So that is what we have when we have a variable changing. That's what the word variable means. It can change. Talk to your parents, or if you're a grown-up watching this and you know, if, like, say you own your house and you have a mortgage on that house and you're on a variable mortgage, you know that that mortgage is subject to change. So 1 month you might pay one amount, and a different month you're going to have something else to pay. Could be more or less depending on the rates of interest at the point in time. But that's a variable. Now, why did I tell you that? Well, I wanted to distinguish between what an identity is. And an identity in maths, we use a triple line for our equal sign. So rather than a normal equal with 2 lines, we will have 3 lines. If you ever see that in maths, it means that those 2 things are identical, or in other words, they are always going to be the same as each other, always the same. Let's look at some examples of some identities here. So first of all, I started with a number example. Show that the stuff on the left is the same as the stuff on the right. Well, this one's an easy one. So we're going to smash through this really quickly. So I know that 10 add 5 is going to be 15. And I also know that 20 take away 5 is also 15. That's identical. So those 2 number sentences on either side, well, not number sentences, but call it number expressions. They are identical to each other. Okay, now let's go down where things get a little bit more interesting. So now we're going to put some algebra in here. Does 2x plus 3 is it always the same as the stuff on the right hand side? I don't know. Let's go find out. So the first thing that we need to do is expand this bracket. Now, if you don't know how to expand the bracket, click on the pop-out banner up here and go and check my video on expanding brackets. But I'm going to assume that you know how to expand it, and I'm going to get on. So the first thing I'm going to do is expand that bracket. So I'm going to multiply the 2 times x. That gives me 2x. And I'm going to multiply the 2 times that 3. And that gives me 6. So now what I'll do is I'll work out the bits on the right hand side. I'll choose a different color and then see if they are the same. So now let's go for blue. Now the first thing I'm going to do is I'm going to collect the like terms. I'm going to add together the things that are the same. If you don't know how to collect like terms, click on the pop-out banner up here and go and watch my video on collecting like terms. Anyway, let's collect like terms. So the 6x take away the 2x, that's going to be 4x. And then the 5 plus the 1, that equals to 6. Well, is it the same? No, it's not. So these two are not identical. So I'll put my triple equal sign and put a line through it. They are not identical to each other. Okay, so this question says, show that the one on the left is identical to the one on the right. Well, I couldn't show that because they are not the same. All right, good. Let's carry on then. Let's go on to the third part of our questions where we're going to have to expand the bracket again. But now they tell us that they are identical. So it says that find the value of k if the one on the left is identical to the one on the right. Okay, I said k, but instead of k, I put a. Don't know what I was thinking when I wrote that one down. So let's put the k back in there. All right, here we go then. Let's go. Expand the bracket. We all know how to do that by now. So that's going to be 2x add 10. All right, and that's because 2 times x and 2 times 5. And then we're going to now look at the right-hand side and see the things that are the same. Well, I'll just use my highlighter. I've got 2x and I've got 2x, so I know that they are the same. But the 10 has to equal to 1 plus k. So 1 plus something has to be 10. And that something is going to have to be 9. So then k is equal to 9. And that's it done. We've found what k is. Okay, so because that has to add up to 10. All right. Okay, let's move on down the bottom one. And again, we need to find k. And I have put an a there. Really wasn't having a good day today, was I? So let's go and put a k in there because that's what needs to be there. Okay, so here is how we're going to work out this particular question. Let's go and see if we can expand those two brackets and see things we can match up on them. So we're going to start with 3x squared, take away 6, because 3 times 2 is 6. Then we're going to work out the right-hand side now and see what we've got. So we're going to have 6k x squared, take away 12k. Right, now once we've got that, it's really easy for us to figure out what k is. Because how are we going to figure that out? Well, we're going to have to match some bits and pieces up. So for example, let me highlight now. I know that this 6 here has to equal to 12k. So let's use it and go and find k. So here we go. Right, so now I'm going to go back to black and I'm going to say that 12k has to be equal to 6. So if I divide by this 12, because I need to get rid of that, so divide by that 12 and that 12, and that's going to tell me that k will equal to a half. And then that question is finished. So as we go along, the identities get a little bit more challenging, and I hope that you're able to see what happens there to work that out. Okay, finally, we got a whopper on the bottom. This one is proof that all the stuff that you have got down on the left-hand side is equal to all this stuff here on the right-hand side. Well, let's see how we do. For that, I'm going to use this space over here, and I'm going to use a different color to see if we can separate that from what we're doing. Let's do the left-hand side. So I'm going to write LHS, left-hand side, is going to be 3x add 2 all square, take away x add 4 all square. Now, because we've got these brackets squared, we have to work them out separately as double brackets. Okay, so let's go and do that now. So I'm going to have to work out the x add 2 times x add 2. When you see a square, do not just square the x and square the 2. You must put those two brackets as separate parts and then multiply them. Now I'm going to multiply them using FOIL or expanding double brackets. If you don't know what that is, click on the pop-out banner up here and go and watch my video on expanding double brackets. Anyway, let's expand these double brackets. So I'm going to use my FOIL, so I'm going to use the first. So that's going to be x squared. Then the outer, that's going to be 2x. And then the inner, that's going to be 2x again. And the last, which is going to be 4. I can simplify this to x squared plus 4x plus 4. Now I'm going to do this one here. So let's change color for that. So that's going to be x take away 4 and x take away 4. We're going to use FOIL again. So first, x squared, outer, take away 4x, inner, take away 4x again, and then the last, which is going to be add 16 because we've got a negative times a negative there. All right, cool. So now we're going to simplify that. And so that's going to be x squared, take away 8x, add 16. So now I'm looking back at my question, which is down the bottom of the page. It doesn't look like that just yet. It looks a massive mess, doesn't it? All right, let's see if we can simplify this now. Now this double bracket works out to all of this here. And this double bracket works out to all of this here. So I'm going to take these two things and I'm going to put them in those places there. So let's go back to black now. Yeah, let's go back to black. So that's going to be 3 times x squared, add 4x, add 4, equals to, oopsie, sorry, I forgot, take away x squared, add 8x plus 16. So what I've done is, right where the x plus 2 is, I've replaced it with all of that. So see, I've still got that 3 there. And then I've replaced this with that. So that's what's there. Then you've got your takeaway. And then I've replaced this with that. And that's what's there. All right, cool. Now, let's expand these two brackets and then see if we get what's down there. So expand with the 3 first. So 3x squared, 12x, and 12. Take away x squared, add 8x, take away 16. Now if you're wondering how I got this here, this is a -1 on the outside here. Let's put it there so we can all see it. Let's bring it to light. When you don't see a number, 1 is there. So -1 times x squared gives me -1x squared. Minus times a minus gives me +8. And then that minus times 16 gives me -16 there. Now let's simplify. So we're going to collect like terms again. And to collect like terms, I've got 3x squared take away 1x squared. That's going to be 2x squared. I've got 12x add 8x. That's going to be 20x. And I've got 12x take away 16x. That's going to be -4. Not x, sorry, 12 take away 16. I do beg your pardon. And that's going to be -4. Does it look like that? No, but it looks like they factorized and took a 2 out. So I'm going to do the same thing. I'll take the 2 out and then I'll be left with x squared add 10, take away 2. And this is identically equal to the right hand side. So yes, we have proven it. It's perfect. It's done. All is healthy. Now, if you don't know what factorization is, click on my pop-out banner up here and have a look at this video called factorization, and then you'll see how we move from this point to that point. All right, that will end it for us today, guys. This was a bit of a mouthful, this topic of identities. I hope you've learned something new. If you did, please give this video a like and don't forget to subscribe to the channel so you don't miss any upcoming videos. What do you think about this topic? Put it down in the comments below. I'll be happy to see your thoughts on this particular topic. But for now, until I see you on the next one,